Hi there. Today we reviewed the topics from Unit 7 in preparation for our test on Thursday. And so as I walk through these are our problems from our review activity. My recommendation would be to pause the video after I give the question or give the problem to try it on your own. And then to start the video again if you get stuck and need kind of that next step, or if you're done and you just want to check your answer. Okay, so the first thing we looked at was reviewing how to name a line. Okay, so naming lines, we pick any 2 points and we can use them in either order. Okay, or we can name it by the singular lowercase letter that exists without a point. Right, and so for this one, my question is going to be, what are some other names for line M? Okay. So some other names, we could name it DE, EF, or DF, right? DE, EF, or DF. Or in the reverse order as well, we could call this ED, FE, or FD. Because it doesn't matter which order you put it in, make sure you include this line symbol. Okay, so my next question. Give you another one to try here on your own. Okay, what are some other names for line L? Well, some other names: AB, AC, AD, BC, BD, or CD, or the reverse order, right? Any 2 points, and you've got the name of a line. Next, we looked at naming angles. Okay, so if given a diagram like this one, okay, and my question is going to be, okay, can you give me a name or other names for angle 1? Okay, what are some other names for angle 1? Okay, so to name an angle, you use the 3 letters that trace the angle. So here's angle 1, and our 3 letters, and we have to say them in order, which means our vertex is going to be in the middle of our 3 letters, right? So our 1 angle would be BAD, or you could do it in the reverse order, DAB. So then my next question is going to be, what are some other names for angle 2? Okay, some other names for angle 2. We have DAC, because that traces angle 2 here, DAC, or the reverse order, CAD. Okay, next we looked at, or we reviewed how to name a ray and how to identify what are opposite rays. And so I gave this diagram here. Okay. To name a ray, you pick an endpoint, and then you use a point that goes in the direction you're wanting to name. So for example, if I wanted to name this ray, I'd use UZ, because it's UZ. Or if I wanted to go in the opposite direction, I'd use UX. So our ray would go in that direction. And these are what are called opposite rays because they share the same endpoint. They both start at U, but they go in opposite directions. And so what are some other opposite rays here? Well, we could do UY and go in the opposite direction from UY is UW. Or we could do UT and going in the opposite direction of UT would be UV. Okay, all of those are opposite rays. Okay. Next up, we looked at how to identify where 2 planes intersect. Okay. And so we gave intersection of 2 planes. And we know that 2 planes intersect at a line. And so if I gave you this diagram, we had A, B, C, D, E, F, G, H. And I asked you, okay, where do planes A, B, C, D and C, E, F, D intersect? Oops, sorry about that, I was off the screen. Okay, so here's our diagram. Where do planes A, B, C, D and C, E, F, D intersect? Okay, well, two planes intersect at a line. We have A, B, C, D, which is up here. We have C, E, F, D, which is this side one, so they intersect at this line, which is C, D. The other way you can know is look at their names. And this isn't true all the time because you don't have to use 4 points to name a plane, but if they use 4 points, look at their names. They both have in common CD. And so that might be a clue as well as you're trying to look at the picture and trying to see where they intersect. Look at their names and let that help you out. Next, we looked at naming planes. We reviewed naming planes. Okay, to name a plane, you use any 3 points in the plane as long as they are not all 3 collinear, which means that all 3 can't sit on the same line. So you can have 2 that sit on the same line, but at least one of them has to be off of it. And so we're going to use the same diagram that we had up above there. And so we have our X, our U, and Z, and then our Y and W. And coming out of the top here, we've got T and V. Okay, and so I want to know what are some other names for plane YUZ. And notice we can call this plane YUZ because Y, U, and Z are not all on the same line. Y and U are, but Z is not on that line. U and Z are, but Y is not on that line. Okay, so this one's good to go. So what are some other names? 2 points, 3 points, 2 of which can be on the same line, but at least one has to be off the line. Okay, so some other names, we could call it plane YUX, right? They are not all on the same line. We could call it plane XUW. We could call it plane WUZ. And they don't have to go in that order either. You could call it WZU, right? We also could call it plane XYW, X, Y, and W. We could call it plane Z, W, and Y, or plane X, W, Z. Oh, and one more. We could call it plane Z, X, Y. Z, X, and Y. Okay. Okay, next up we looked at naming vertical angles. Okay, so vertical angles. Vertical angles are made by two intersecting lines. So for example, we were given this one here. We were told this was 1, 2, 3, 4, and 5. And so then my question for you, what are the vertical angles? Okay, well, the vertical angles would be angle 1 and angle 4, because those are the ones that are made by two intersecting lines and they meet at the vertex there. Okay. Or how about one like this one? Okay. My question for you, what are vertical angles? Well, you could name angle ABC, which is this angle here, and angle FBE, which is this angle here, because they're made by those two intersecting lines. Or you could name angle ABF, which is here, and angle CBE, which is there, because those are also made by the two intersecting lines. Okay, next we looked at calculating distance. Our distance formula is the square root of the quantity of x2 minus x1 squared plus y2 minus y1 squared. And so I'm going to ask you to find the distance between 3, 5 and -1, 2. Okay, the distance between 3, 5 and -1, 2, we do square root. Our x is subtracted, which is 3 minus -1 squared, plus our y is subtracted, which is 5 minus 2 squared. Okay, and so then you get square root. 3 minus -1 is 3 plus 1 squared. 5 minus 2 is 3 squared, which is 4 squared, 16, plus 3 squared, 9. And 16 plus 9 is 25, and the square root of 25 is 5. Which, if we had at the beginning, plugged that into our calculator, square root 3 minus -1 squared plus 5 minus 2 squared, we'd still get 5. Okay, so next up, we reviewed finding the midpoint. Okay, so finding a midpoint, there are two ways you could potentially see this. One would be looking at a number line, and so finding kind of the middle there, but in either a number line or the second way, which would be on a coordinate plane, we can use this idea of averages. Our x1 plus our x2 divided by 2, and our y1s plus our y2s divided by 2. And so I'm going to say, find the midpoint of 3, 5, and -1, 2. Okay, so midpoint, we add the x's together, 3 plus -1 divided by 2. Add the y's together, 5 plus 2 divided by 2, which is equal to 3 plus -1 is 2 divided by 2. 5 plus 2 is 7 divided by 2, which is 2 divided by 2 is 1. 7 divided by 2 is 3 5/10. Okay, next up we looked at finding the length of segments on a number line. Okay, so if I had this number line here, this went from -5 to 5. And I asked you to find BC, which means find the length of BC, the distance from B to C. Okay. Well, BC is from -4 to 0, which is a distance of 4. How about find the length of AD? AD goes from -5 to 4, which is a distance of 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 segments. Or 4 minus -5 is 9, whichever way you want to think of it. Okay. Next up, we looked at what would be AB if, the length of AB I should say, what is the length of AB if B is the midpoint of AC? So here's where we started getting into some more algebraic applications of our geometry. So this would be your diagram. Okay, so if we have the fact that B is a midpoint of AC, midpoint means the middle, so both sides have to be the same, right? It's been cut in half. And so with that fact, I can take this 4x minus 1 and I can set it equal to x plus 8. And then I can solve for x. I'll subtract the x from both sides. I'll get 3x minus 1 equals 8. I'll add 1 to both sides, which gives me 3x equals 9, which means x equals 3. But that's not my answer, because my question is, what is AB? The length of AB. Well, the length of AB is 4x minus 1, so I'm going to take that 3 and I'm going to plug it in. So AB is going to be 4 times x, which is 3, minus 1, which is 12 minus 1, which is 11. So again, this is when we have a midpoint. We know the two sides are equal to each other, and so we can set those two equations, or set those two expressions, equal to each other. Okay. Similar to that concept is the idea of a bisector. Okay, so if we have that BD bisects angle ABC, and we know that the measure of angle ABC equals 82, what is the measure of angle ABD? And so here would be our diagram. We would have our angle ABC, and BD would be bisecting it. Well, if it's been bisected, that means it's been, like a midpoint, cut into two equal pieces. And so if ABC, which is my big angle, it's my overall angle, ABC, the entire thing is 82, and it's been bisected, it's been cut in half, what would that mean ABD is? Well, it would mean it was half of the overall, half of 82, which would be 41 degrees. Or a similar thought process, but just in reverse order, if we knew that BD bisects angle ABC, and that the measure of angle ABD is 39 degrees, what is the measure of angle ABC? So same diagram. We have A, B, C, BD has bisected it, which means these two pieces are cut in half. ABD is 39 degrees. And I want to know, what is ABC? What's the overall? Well, there's two ways to think of this. You can think of it as, well, the overall being twice the half, right? Since this piece is half of it, because it's been bisected, then the big one should be twice as much. Or you can fill in. This is the other way of thinking of it. If it's bisected, then that means these two have to be equal, right? The big angle's been cut in half. So if that's 39 degrees, then this has to be 39 degrees. Well, if they're both 39 degrees, what's the total of ABC? It's 39 plus 39, which is 78 degrees. Okay. Okay, next up we looked at another similar line of thought, which is that if angle DRC and angle CRB are supplementary angles, there we go, are supplementary angles, and if we know that the measure of angle DRC is equal to 2x minus 3, and the measure of angle CRB is equal to 5x plus 1, what is the measure of angle DRC? Okay, well, if these two are supplementary angles, CRB and DRC, then those two angles, when added together, should make 180. That's the definition of supplementary, that they add to make 180. So we're going to take that 2x minus 3 and we're going to add it to the 5x plus 1. And it's going to equal 180. So we can combine like terms. 2x plus 5x is 7x. Minus 3 plus 1 is minus 2. Okay. So then we're going to add 2 to both sides. And we get 7x equals 182. So then we divide by 7 and we get x equals 26. Well, that's not my question though. My question is, what is the measure of angle DRC? So I need to take that x equals 26 and I need to plug it back in. The measure of angle DRC is equal to 2 times the 26 minus 3, 2x minus 3, which is 52 minus 3, which is 49 degrees. Okay. 2 more concepts here. We have vertical angles. Where are we? Okay, we have angle AFG and angle BFH are vertical angles. The measure of angle AFG is 2x plus 5, and the measure of angle BFH is 9x minus 9. What is the measure of angle AFG? Well, vertical angles are congruent, and so it's going to be a similar thought process to our midpoint, in which case, or in which situation it split the segment into 2 equal pieces, and so we set them equal to each other, or our bisects, which cut it in half, and so we were able to make the 2 halves equal to each other. Well, vertical angles are congruent. They are equal to each other. And so I'm going to take that 2x plus 5 and I'm going to set it equal to the 9x minus 9. So I'm going to subtract 2x. And I get 5 equals 7x minus 9. And then I'm going to add the 9. And I'm going to get 14 equals 7x. And then divide the 7 and we get x equals 2. But again, my question is, what is the measure of angle AFG? Well, AFG is 2 times x, in this case x is 2, plus 5, which is 4 plus 5, which is 9 degrees. Okay, last one here. We have a diagram. And our diagram looks like so. So there's our diagram. And we are told that the measure of angle ABD is equal to 121 degrees, and we are asked to find what is the measure of angle CBD. Okay, well, ABD is 121. That total angle is 121. And it is made up of two parts. Well, if I knew what these two parts were, maybe this one was 50 and this one was 71, how would I get the 121? Well, I do 50 plus 71. And that would give me 121. And it's the same thought process here. We have two parts that we know make the whole, that we know make the ABD, that we know make 121. So what am I going to do? I'm going to add those two parts. I'm going to do 4x plus 2 plus 3x minus 7 to give me 121. Okay, so then we're going to combine like terms. 7x, combine like terms, minus 5. So then add 5 to both sides. 126, divide by 7, we get 18. Okay, well, now that we have what x equals, we want to know what is the measure of angle CBD. Well, the measure of angle CBD is 3x minus 7. 3x, which is 18, minus 7. Well, 3 times 18 is 54. And 54 minus 7 is 47. And there's my answer.